Self-induction. Whenever the current in a coil increases or decreases, there is a change in magnetic flux linking the coil. Hence, an EMF is induced in the coil, which is called self-induced electromotive force, and this phenomena is called self-induction. The number of flux lines linking any given circuit due to a current in the circuit itself will depend on the geometry of circuit, that is, its shape, size, number of turns, etc. Statement. The phenomena in which an opposing induced EMF is produced in a coil as a result of change in current or magnetic flux linked with the coil is called self-induction. Experiment. Consider a coil connected a battery and a tap key as shown in the figure. Diagram. When the key is pressed, the current starts growing through coil. As a result, the flux linked with the coil also starts growing through it. This produces induced EMF in the coil. The direction of the induced EMF is such that it opposes the growth of the current in the circuit. When the key is released, the current in the circuit starts decaying. As a result, flux linked with the coil also starts decreasing, which in turn produces induced EMF in the coil. This also opposes decay of current in the circuit. It may be observed that an opposing induced EMF is produced in the coil during both growth and decay of current. Consider a coil of N turns carrying current I and phi be the magnetic flux linked with each turn of the coil. Then N phi will be the flux linkage in the coil. Since the flux is due to current in the coil, the flux linkage will be directly proportional to the current I. That is, N phi is directly proportional to I. From Faraday's law, EMF is Ez is directly proportional to minus derivative of N phi. Equation 22. Es is directly proportional to minus di by dt, equation 23, or EMF equals to minus L di by dt, equation 24, where L is constant of proportionality, is called the coefficient of self-inductance of the coil. Negative signs show that opposing nature of induced EMF. If we consider magnitude only, this EMF is equal to L di by dt. If di by dt equals to 1 ampere per second, then EMF equals to L. Definition of self-inductance. Self-inductance of a coil is numerically equal to the induced EMF produced in the coil. When the rate of change of current is unity,